Hello and welcome to another live coding with Gerph. It's apparently very dark in here, so you're just going to have to suffer a little bit of a dark image until I fix that. Yes, so yeah, we're doing some live coding today on the system variables module. I'll just do a quick bit of admin. I was out getting married last weekend, so there was no session. So sorry about that, but I was sleeping pretty much. It was a very tiring day. Yes, and the other thing was, don't go... So Dave says, sorry ladies, there's only ever been one girl for me. Anyway, yes, anyway, and it's completely derailed what I'm thinking about now. So what was I going to say? What I was going to say was, yes, don't upgrade your software just before you go live, because that also is a delay and problem for things. Yes, it was very, very joyful. We had a really lovely time, and really, really enjoyed it. And we're married. Way! I got a ring. I wasn't going to wear a ring, but I got a ring now. It's really lovely. Anyway, yes, I am going to be just giggling. I'm sorry about that. We just live with it. There was lots of cake. There still is cake left. We are working through. We did some lovely cupcakes so that we could all enjoy them and send them to people that couldn't make it. So yes, we've had a really nice time with that. Okay, so I'm also trying to remember where I was up to on the coding, because it was a little bit of a while back, so we're gonna have to think back. And if I remember rightly, I went and posted up to say what we've done. So let's just have a look. Status update. That was a general 64-bit work. That's not the one I wanted. Oh, did I not do a... I must have done a post for this. Live coding 27th. Did I not do a post for this? Surely. Oh well, if I didn't do one... Oh no, because I don't do them in 64-bit, do I? I do them in announcements. Yeah, I know how this works. Sunday the 19th of October, that's correct. So this week I'll be looking at adding code variables and hooking into the OS SWIs. Right, so now I know. Alan's after more cake. They were very yummy. Yes, so code variables. So so far we've got the regular string variables, macro variables, evaluated variables. Oh yes, she had... Sorry, Talia Brown had said hiya earlier, and then a moment later Talia Ferguson said lol. Hey. Yeah, today may be a little bit of giggly. Yay. Right, yes, my wife and I are very happy. Yeah, it's internet official, says Alan. Yeah, unfortunately changing your name is always a bit of a palaver, bit of a faff, but yes, that's just one thing we have to handle. My wife Talia Ferguson. Whee! Yes, I'm in my 40s, not a teenager anymore, not yes, sorry, distracted. So you're not going by Charlie Brown now? No, I'm not. That had not actually, I think it had actually been mentioned some time back, but I had forgotten about that. No, it's Ferguson. We're losing the Brown. Completely derailed, completely losing my thoughts. The Riscos bachelor boy is no more, says Alan. Yes. I'm trying desperately to try and get back onto the track of what I'm trying to do, but it's just, hey, happy. I wonder if I do this. Does this make it any more? Oh no, that's even worse. Even less. No, get down. That. How's that? Oh, hang on, I've got lines over here, haven't I? Ah! We have lights. I need to sort out the backlights. Yeah, nobody's going to be fighting over me. Not least because they could just go take a running jump. Anyway, we have some decent light on us. I can probably sort something out with the lighting in here later. I said I would do that like 3-4 weeks ago, so we'll see if that happens. System variables. Yes, we're trying to do code variables and the OS SWIs, which should be pretty simple. Code variables are not especially complicated. We just have to call an entry point and get back some data. I have to remember how that works, but that's what we have to do. So let us have a see. Do I want to wire it into the OS interfaces first, or do I want to set it up so that it's doing code variables first? If I wire it up to the OS interfaces first, then I can just use the standard modules to go and actually register variables, and I don't have to do anything tedious to be able to get the environment working. I think I might do that. I think I may just do that. It will be easier. Yeah, so we're going to implement the OS variables first. So, hello kittens. Implementing OS variables isn't all that hard. Come on, how do you pick up? There we are, thank you. OS variables are OS interfaces, claiming the OS SWIs. Isn't that difficult, and I have done it before. So I did it on conversions. So let's have a look at conversions. Modules, Riscos source, not resource FS, kernel extracted, conversions to. So anyway, this is the conversions module, and I don't remember how this works, so we're going to have to just sort of look at the OS SWIs. Okay, it's just like this. We claim them with one call and we release with another. And there's a header file. Actually, we don't need that. OS SWIs. Yeah, there's the header file. Why is the claim and release interface not defined in the right place? That should be in the header file. Oh no, because we pass in the value claim. That's okay. Oh yes, yeah, so it's actually quite a nice interface. Okay, so bounce that one over here. Bounce this window over here. So this is the conversions window, and this is the SystemVars window. So I'll give you the background to this. When back in Riscos 3 all the way up to 3.7, well, all versions up to Riscos up to 3.7, they didn't have a nice easy way of replacing the operating system SWIs. So all of the OS_star calls couldn't be replaced. There was, however, a magic address that if you knew, you could collude with the kernel and use that address to poke the right values into there to claim those SWIs. And you had to know that there was another address inside the kernel that you had to return to that was also a magic address. They were both at 1FO something or other, I can't remember, somewhere next to the IRQ stack, I think. And that's how you used to claim things. And there was very few things that needed to do that, one of which was task window, because we all hate task window. Task window and with the window manager in general are a blight on the rest of Riscos. So in Riscos 3.8, or was it in Riscos 4? I can't remember whether it was one that we implemented or whether it was one that was implemented for Riscos 3.8 and we took on with 4. There was a new call, claim OS SWI. There was also claim SWI as well. I think claim SWI came first in the 3.8. It was defined but not actually implemented. And because at the time, yes, this is right, at the time, I didn't want to do the full implementation of claiming any sort of SWI. I thought that was really going too far because it basically means that you can hijack somebody else. And there are times when you want to do that. I'm looking at you, NetEye. But generally, you don't want to do it. You have a handler and they should provide interfaces to export their interfaces rather than allowing people to replace them. I mean, maybe that's not right, but that's the way I viewed it. And so the claim OS SWI call was created, and this allows us to claim a SWI, and we pass in claim or release, and we can pass in the function we want to call and what the private word should be that's passed in R12. And that is the interface that we can use. And that is implemented in Riscos 4. I believe it's implemented in Riscos 5. Let us have a look and check. Riscos OS claim OS SWI. I'm pretty sure that it's claim. I mean, Alan would know because he did most of the documentation of this. Claim OS SWI. Oh, it's not there. Not listed. Interesting. Maybe it isn't an implemented call in Riscos 5. Well, that's their problem. The reason that it exists is so that you're not colluding with the kernel, so you're not having to know things about the rest of the system. And I am a very strong believer that there should be clear separation between the components, and so I will enforce and try and do that. If somebody wants to do it using nasty collusion and all the rest of it, then, well, that's their problem. That's Riscos 5's issue. If Riscos 5 does not wish to follow good engineering practices and just hack stuff together, that is their choice, but that's not what I'm going to do. So anyway, general mutterings and complaints apart, this is the interface for claiming SWIs. So what we do is we're going to copy this into here. So create a new file called OS SWIs. I mean, this could be a library, really. I really could move this into a library, but I haven't. And so that will just have to happen some other time. New file, OS SWIs. This is a header file. I'll copy that over. There we go. That's copied over as well. And then we need to add that to the make file. So here we go. In the make file, we just need to add o.os SWIs. And then we need to know how we call it. So if we have a look in module here, we'll see this is how we call it. Register OS SWIs is what's done. Ah, yes, and it looks like in here I've actually made it so you can choose to have the OS SWIs or not, which makes sense because you sometimes won't want them. So let's do that same way. In the module code, we'll have whether it's registered. We only need one flag to say that we're registered because we're only claiming, or 2 SWIs are actually registering at the moment. That's fine. And here we go. This is the call here to register it. Claim OS SWIs. Does SystemVars not have any init calls in it? That's interesting. Should be a sysvar init, surely. Okay, we'll come back to that. And then this one is the release them. Oops, there we go. Copy and paste. And we probably should release them here, I think. Do we release them first? Yeah, release them before we go and shut down the SWI system. Does that make sense? We can always move it around, but I think removing the SWI calls first is probably a good idea for now. So here's the implementation of SWI read var val. This is the one we've got. This is the implementation of SystemVars, and these are exactly the same implementations in the SWIs as they will be in the new calls. So we spin down to the end here. Here we go. This is how the conversions are all implemented. They're just a simple call and then jump into the implementation code. Conversions are very simple. They're really not that complicated. But, oh, look at this. This is all fun, isn't it? Module SWIs, and then the OS SWIs. Yeah, right, look at this. Actually, this looks very much like it can just go straight in. I think, yeah. So, entry point is OS SWI, not convert hex. We want read var val, and this one is set var val, and they want to call into what's it called? SWI read var val with the value of doesn't really matter, and R and private word. And private word. I think that's right. I think that looks pretty much spot on actually. SWI set var val. There we go. No, we don't need to, these are not hex ones though. Okay. How does that look? That looks like it's probably doing something. Possibly, don't know. So OS SWIs. And we've got the debug commands as well. And we've got just the SWI interfaces. I think that looks reasonable. Probably going to do the right thing, maybe. Where's the register call? Is that at the end? Ooh, that's nasty, isn't it? That's a nasty thing. Oh, right, I see. Because we register each of them in an interesting way here. Okay. So here's the code. I mean, probably we don't need to do it quite this way, but it's not a big deal. Register. We need to just replace these with entry points for SWI. Sorry, entry read var val and set var val. Read var val and set var val. So what this is going to do, we don't actually need some of this code here, because what it's doing is it's doing the claims and the registers, and it's saying if some of them don't claim and some of them don't register, we'll just remember which ones we've done and not. And in the conversions module, there's more than 32, so I had to have 2 sets of variables to use. But we don't need to worry about that here. Yeah, so this is register. We don't need all this magic. We just need to handle just one of the variables. And then that one, it's always this. Okay, I mean, again, this is probably way more clever than we need it to be. Yeah, but doesn't matter. It's okay. All right, so let's build that and see whether it works, shall we? Move conversions out of the way. Put this one back again. Yeah. And then we'll try building it. Oh, we can use the magic. Does the magic button work? Well, that looks like it built. But we haven't actually defined the OS SWIs, so it's not actually me building any of those. And I've just remembered, I also need to update this module header as well to include the entry points. So we need this bit here needs to be added as well. There we go, just a bit of that, which is pretty easy. Let's just move this out of the way again and put go to the module header. Here we are. And generic veneers. Here we are. I saw it just then. Where it is? There it is. Generic veneers. And we get rid of that and do an if there. And we need to add a new file. No, we've already added the file, haven't we? It doesn't want to be convert hex. It wants to be read var val. Read var val. And set var val. So one of the things that we could do is we could make a lot of this registration and handling of OS SWIs a lot easier, and other things we could make simpler if we're doing a 64-bit version of RISC-OS. However, if you make it simple, if you change things very much away from how things were, it's going to make things more difficult for people to transition, and it's going to make the code more complicated because you've got to include more conditionals for 32-bit, 64-bit code. So the decision I've sort of made is try and make it as close as possible, but just the bits that are really ugly, like the flag values in the processor state, are the things that are going to change. And in this case, there's none there, so it's literally exactly the same code for the 64-bit and the 32-bit, or at least it should be. We'll see if that's going to be the case, because we know it's not. Now, I need to also make it use the OS SWIs. So let us turn this on. Options. Plus equals turn on OS SWIs. So in theory, we can just turn these on and off by just commenting the lines out, and that will make things easier. In fact, I wonder if we should really do that. Opt equals there, and then each line can be just commented out, and it makes them turn off. I mean, alternatively, you can go and just change them to minors, but yeah, for now, this is good. Right. So with that in mind, we now need to make everything clean. Make RISC-OS AMU clean. And then after cleaning it, we need to build it. Likelihood of this working pretty low. Ah, right. So it doesn't know OS SWI because we didn't include the header. So we go into here and we just go pop to the top, and in here we need to do --include osswis.h. There we go. And we might as well build it in here and get the magic warnings and stuff. Any errors? No, no warnings. Built successfully. Woo. PyroDev. Common load module. What's it called? I've forgotten what it's called. It's called rm32/SystemVars. Not that one. Oh, there's my test code. Actually, let's start loading it just as a plain module and then drop to GOS, and then we'll see whether it is working or not. Okay, well that's interesting. Start show. That's interesting. And the reason that we're not seeing very many variables is because the variables that have been registered in the system have all gone away when the new module was loaded. And there's no way to transition them from the old module to the new module, an old interface to the new interface. But what we can do is rm system. Oh no, SystemVar defaults doesn't actually exist as a module, does it? I didn't create it as a module. Oh. What creates a code variable? Something must create a code variable. Come on. Let's have a see then. Path utils, no. No, those don't. Those don't. Management sprite pool. Does task window create one? I think task window has a task window state, doesn't it? I think it does. I might be able to just reinitialize that one and see what happens. Do we have debug turned on? If we have debug turned on, oh, there isn't any debug in this. Is the debug in one of the other? Oh, we could have put some debug in to like say what we're doing, couldn't we? That would have been useful. Okay, so, well, let's load the system variable defaults module. Everything shut down, okay. So, copy // So, system variable defaults, this module here, again, it's in kernel ext. SystemVar defaults, there we go. So, this module is a very simple module. Again, it didn't exist before. This is a new, absolutely a new one. This one has code variable implementation, and it provides us with a number of the system variables. So if you look in vars here, we register all the system variables for the environment. And the idea is that rather than this being in the kernel, as it had been, or being in the system variables module itself, the default values are actually separated, because then you can change these without changing the system variable implementation. It makes it a little bit easier to update. And here, it's also got a file that it can read as well. Yeah, SystemVars defaults file. So there's a variable that's a file that's set, so you can actually set some of these if you want to override them. And that could be handy in the future to allow people to like have a customized operating system if they wanted. But it has a set of default values that if that's not present, it'll use the other ones. And then we just go initialize them all to set those variables. If we have a look in here, yeah, we just loop through things, I think. No, that's a set variable. Oh, is it in module we do it then? I don't know how this works. Vars init. So it calls vars init. Where's vars init? Yeah. So we load some from a file, and then we set the. That's the wrong way around, isn't it? We should set the defaults first, then read the file. Well, that was pretty dumb, isn't it? Yeah. Because you want the file to override things. Oh, except the file here is only setting them if it doesn't, if they don't exist. No, it's setting them anyway. Read variable, read file. Read file reads the file in and then calls set variable. And set variable. Oh, so set variable does only set it if it wasn't set. So this is actually correct. So this means this lot will, the file will happen first, and then anything that isn't set will get updated to the default value. Okay, that actually makes some sense because it allows the file to be overwritten. Okay. Having gone through all that, this is the module, and in here we've got a built version of it. So we're just going to pinch that, and we can load it. So if we copy from there, im32 / SystemVars defaults to here, and we'll copy the 32-bit version, the 64-bit version as well. We can test out the 64-bit stuff later. That'll be more complicated. And then we want to run it, don't we? So we want to load. Oh, come on. Yeah, this one here. And then after we've loaded SystemVars, we want to load the module SystemVar defaults. Oh, I've just overwritten it, haven't I? That was dumb. So it's that. No. Let's try that again. Copy the 32-bit version as SystemVars defaults 32, and copy the 64-bit version as 64. Now run the 32-bit version. Okay. Whoa. Well, that looked like it did something. Let's just make this window a bit bigger because we're trying to debug this a bit. Okay. So if we do star show, whoa, local variable value. Oh dear. Oh dear. I think my operating system crashes if run $path isn't set. Oh dear. Yeah, it's crashing here. It shouldn't really be crashing, I don't think. So what happened here? We do read var value enumerate. Not value, no, yeah. Value wasn't set. Ooh, that's interesting. So we, no, this isn't. Yeah, my operating system generally isn't working if something about the variables aren't right. That's cool. All right, let's have a look at Pyromaniac. We'll just debug everything at the moment. This is fun. Yeah, let's just go here. All right, and we'll have a look at this. So the problem, where was the problem? It was in API init. Oops, no, that's moved it through the window. This window over here, please. So API why? API init.py. That's the one. And it's the value. No. Enumerate it was in, wasn't it? This is it here. Oh look, yes. So as it was saying in my, have a look in the backtrace. If variable set, and then never sets the value of value. So that's a bit dumb. If it's a number, if it's a macro, if it's a string, but if it's any other type, we don't return it. So, which actually means that whatever type it's returned isn't actually correct because it's been working before. Interesting. So, what was got type? Got type was 16. Oh, that's a code variable. Oh, yeah. Code variables aren't implemented yet, so it's just returning it blindly back to the system. Else, right? What I'll do is I'll actually make this do return unknown type here. And that will at least make Pyromaniac work properly. If we hit this, that means that the OS read var val implementation has returned a variable type we do not understand. Actually return unknown variable. Unknown variable type. Why not include the actual number? Got var type. Yeah. So this won't affect things too much. Let's move it out of the way. But it should mean that we can actually run the commands. Finding bugs everywhere. It's good fun. Show. Right. Right, good. Sys_date is an unknown types code, and then we've got that there. Interesting. It hasn't set the run path and things. Why did SystemVars not do that? SystemVar default should have done that. SystemVar arc, no such variable. System variable not found. Okay. What does it use to check? Ah, it's checking explicitly for var can't find, which makes sense. It should be using the error number, which probably means I'm not returning var can't find. So let's go and see if we can fix that in here. Where's my error blocks? Errors, I've lost errors. Come on, errors, please. Errors. System variable not found. No such variable should be that value. So let's just copy it from here, paste it into there. I wonder if there's some other error numbers that we should be using as well. Well, there will be other errors, I know that. Riscos kitten, new errors, yeah, there we go. Right, so var can't find. Right, so var no room should be our no memory error. There we go, that one there. Bad var type. Bad var type, there we go, that one there. Bad variable name, there we go, that's this one. Oops, no, let's just pull back, sorry. Name. Apparently there's a bad macro value. I wonder what that means. What could be bad about a macro value? I'm not sure. I actually don't know what that means. What I'll do is I will copy that and put it here. It's possible I should actually be using the string versions as well in this, but yeah, let's not overcomplicate things right now. Oh, hang on, there's a semicolon. Fix me. I'm not sure what could be bad. There we go. And there's also a variable value too long, which I think is not the buffer overflow one, but there we go. Variable value too long. There we are. So now we've got some actual error numbers that are consistent, which is good. So we should, in theory, be able to build this. Where's my build command? Riscos arrow. Stupid preprocessor. If you're in a comment, it still thinks you're doing quoting. I am not sure. It's not, maybe not stupid, I don't know. Right, so that's there. If we now try and run it again, we'll see whether we get a bit better on this one. Oh, there we go. It's managed to set some variables. Show, just do show again. We have some variables, and that was actually quite quick, wasn't it? The enumeration was surprisingly fast. I genuinely expected the enumeration to go slowly, but it's gone quick. It's good. And we should also be able to do show sys star. Hey, wildcarding works. Excellent. Okay, so now we've got some system variables set, and we've given ourselves some error numbers that are valid. One of the things that's interesting here is we're actually managing to set this variable type here, and we should have really been returning bad var type. there. So let's have a see why that was allowed. So we have a look in module and we look at the calls here. So not read var val, in set var val. In set var val here, write a variable value. If it's a string, if it's a macro, if it's a number, if it's expanded, if it's a code variable, just break, don't return. Ah, that's why. So we didn't actually return a bad type at that point. We just said, it's not a code variable. We're going to just pass it straight through. That's why. That's a bit silly on my part. Okay. Yeah, I was just curious. I could see the edge of the window. I didn't realize I had done that. Let's do that. There we go. Oh no, I don't want to do that. I want to do that. I'll do that. You want to do that? Do it. Yeah, fine. I'm wittering now. So let us commit this code because I think we're at a good checkpoint here. So add c/os swis and h/os swis. I wonder if I should add the system variables as well, the defaults ones as well, because they're actually useful tests. And then we could add them into the test code that we commit. That might be useful, mightn't it? What have we got test-wise? Anything? We haven't got any tests yet. Yeah. Tests. Mov. SystemVars default star. Actually, I want to get rid of the old one. That one there. That one is confusing. So we have got test set read. There's a basic program there that does things. That's not bad. Yes. So yeah, if we move SystemVars default star to tests, we could probably move test set read into tests as well. Yeah, and then if we have a look at our workflows here, oh no, it's not the workflow, it's in the row build. Row build, here we go. So we build the tests, yeah, and then we run vars test, cool. Then we build the module, then we load SystemVars. We do a simple test of reading it. Then we should be able to do load the defaults module, which we do imload tests / SystemVars. Oh no, we're in Viscos at this point. Dot SystemVars defaults 32, and then check that OS SWI enumeration works. Star show. We're not checking the value that comes out of it there, but I don't think that's a big deal right now. We just want to know really that it doesn't crash, because that's kind of important. And then kill the module, and then we report success. Okay. Status. Add tests. Ooh, except my test code is no longer there, is it? It's in tests. Test set read. Bum, bum, bum. Okay, and it's worthwhile as putting this onto a branch. So this is the implement OS SWIs. That doesn't look right. That way, yeah. Commit -a. Add an implementation of the OS _star SWI calls. set var val and os read var val are now able to be hooked into the os by replacing the os SWIs. So of course this code is going to be on GitHub, so you'll be able to see it, and other people will be able to copy this style of implementation to do other things if they need to, and make better implementations, or they can turn off the OS SWIs and it will then just work on a regular RISC-OS system. Bum, bum, bum. And yes, that's good. So now if we go and push that, push means you, and I'll just make it update the tracking branch. And if we then go and have a look at it, it should be actions. Fingers crossed, because I don't want to give you a feedback right now. I'll leave it open because I might want to talk to them later. Ooh. All right, so 3 questions. What's it got? How satisfied are you? Extremely. The actions allow me to run code that is testing my implementation. How could we improve it? I'm not sure actually. Sometimes debugging what went wrong is hard. Often the permissions are confusing. Which of the repository permissions are allowed for which operations? The errors. I mean, it's entirely possible it already does that, but I'll give them the info and they can hopefully find something out. Right, where were we? I was looking at the workflow runs and it failed. What did it fail? What went wrong? It built it. No run action specified for file. Oh dear. So what we've tried to do here is we've tried to run a basic program, but of course the basic program is executed by using one of the alias variables. So if we jump back over here and I just run pyro normally, and show star fd1, you can see that these variables are set, which will then cause it to go and run that file in BASIC. But of course that doesn't exist because we've gone and erased it. What I could do, yeah, I could reinitialize the file types module, which does that job. So if I go in this code here, before we do this, this will set a number of other variables. Reassert the file types variables. XRM reinit file types. Okay, commit as a and amend that to there. No change. Push, force push that. And let's have a see. Here it goes. And these are a lot faster runs now that we're using the native compilation. Whoa! Look at that. So here we go. Variable creation did a bunch of things. Variable reading all correct, all passed. And then we build a module, and then we run the basic test here that goes and tests different variable types, and we get those working. We're testing the enumeration and the deletion, and oh, it fails the tests. Why did it fail the test? What error did we see? Iterated too many times. Oh, it says iterated too many times because there are more variables than it's expecting. It's only expecting the ones that it set. Oh, maybe I should only set the run type for basic, and then we'll load them on. Yeah, we'll do that. We'll do that. So this thing here, we'll just swap these around because this test here is expecting to have a very limited environment. So here we'll do, copy this. That will still do, but we'll do it after we've done this. And for this one, we'll do set alias run type blah to be basic minus quit. Oh, we probably need to put this in quotes as well, don't we? Because it's got quotes already. That needs, and then that needs a quote that's escaped for this. How do you escape? You escape quotes with that, don't you? So this is reasserting the basic run type variable. There we go. And then we'll go and test that. We'll get all of the file types in, we'll get all of the defaults in, and we'll do a show and see that everything is working. So try that one. Push force and have a look at it. And there's a basic test, that's the basic program. No, that was the basic program up here, wasn't it? So reasserted the file types variable. Then we loaded the, no, this is the basic program here. So this all worked and it passed its tests. It has an enumeration of that, and it hasn't read too many variables. And then we get all of the alias variables here. And then we get the file type ones. CLI prompt came from the SystemVars defaults, as did file path as well. And then all of this. Sysyear, systype, and sysreturn code. Well, the return code came out as 0, but I think time and year, they're code variables. And they're not working. Which is okay, I suppose. In fact, what it looks like is they're returning the old value because they're just not initializing it properly, which is a little weird. Yeah, that's a little weird. This is almost certainly just a an artifact of how things are set up in this limbo state where we don't have code variables working. So I'm not going to worry about it. I'm going to just move on and try and start implementing them. So OS SWIs are done. I'm going to declare that done and may as well merge it into master. Did we call it main? Oh, we called it main. That's interesting. I'm happy with that. Not a big deal. Merge, implement, OS SWIs. No, fast forward, please. You can see it merged in. Thank you very much. Okay, and then push that as well. So we've had about an hour. We're doing good. We're going to try implementing code variables. This probably won't take just half an hour. We'll probably need a bit more than that. But we'll just try implementing and we'll see what we come up with. Yeah, this is going to be fun, I think. Just trying to think how it works. Yeah. So best way to look at how it works is to go and look at the code. Look at the definition. Not evaluate SWI, not GS-trans. Read var-val. Set var-val. Here we are. So set var-val, I think it defines in here what the code variable looks like. Here we are. If they're a code variable, then you pass in a block of code, and the block of code is an entry point for write, and then an entry point for read, and then some other segment of code. That's what you do. And then the kernel, in the old case, would take a copy of all of that block. From BRISCOS 3.7 onwards, it calls synchronized code variables, no, synchronized code areas, so that it ensures that that's all being cached properly. And we're not going to execute old code. And then whenever the read entry point is called, it goes and calls the read entry point here. And whenever the write entry point is called, it calls the write entry point. And they get back values to be passed back to the user. It's not particularly difficult. And I think we can make this work relatively well. So let us have a look at what we've got. What do we need to do then? In order to do this, we need code variables. So let us have a look at, where's the module? Here's the module. So if we have a look up here in the module code here, this is the code variables code. There's actually some important things here. So if you have a look in the number code here, oh, is this set or read? This is set. Oh, this is interesting. So if you do a set and the data length isn't 4 bytes, is that going to go wrong? Maybe I won't worry about that one for now. I'll worry about the other ones. But we can come back to that one because that's possible. In fact, I'll leave a note. I'll leave a note here saying, fix me. Do we need to check the length? Because we need to check this against what the original version of BRISCOS does, classic. But we definitely can check the length for the code. So if data len is less than 8 bytes, because the implementation is 8 bytes here, you can't do it if there isn't these 2 entry points, then return what's the error message? It's oh, buffer overflow, isn't it? Buffer overflow, there we go. Do we have to set the, oh no, it's not buffer overflow, it's bad length. Oh, actually the bad length is being returned from here. Maybe I should do it in this bit instead. No conversion needed here. Okay, so that for system variables. Okay, and in here in sysvar update or create, which is in variables, isn't it? We don't check the old name, we don't check the memory exists, we don't check the length. Dear me, lots of things we don't check with this. And for the length, let's read, where's update? Update or create, here we go. Yes, update or create does the create here and then does the read here. Okay, so we should probably check the length anyway, but right now we're not to worry. If the system variable is code or the type is code, return that. Yeah, you can't change the code, the type. That's fair. Dun, 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 dun. So here we go, it is create. yeah, so create, we match the name, we do this, and then we copy the, mem copy happens here, that's right. So what we want to do here is, if it's a code variable, we need to do a synchronized code variable there. So if type equals code var, svt code, there we go, we need to issue synchronize code areas. And we will have a synchronized code areas call somewhere. Where will I have done it? I'll have a system call for that somewhere. Not sure. Modules rep for synchronize code areas. Let's just have a look in all of the kernel X area. Ooh, not in there. Oh, that's a directory. It didn't do it. Oh, there in SystemVars defaults. Well, that makes sense. This is SystemVars defaults. Synchronize code. Not in there. It's in the. Is it in the OS file? No, it's not in there. It should be in there, really. Code vars. Right. So yes, apparently I was wrong. RISC-OS 4 onwards will perform the synchronized code verbs. I think 5 does it as well, but the rest of the system does not. So we need to call it. Oh, this is lazy, isn't it? We're doing it on the whole system. Oh, because we don't know where it's been copied to. We don't know where it's been copied to, so we have to do it on just that region. Yeah, that's a bit unfortunate, isn't it? Well, anyway, we don't have a nice veneer, so I will create a nice veneer. I mean, I could really do with just using oslib here. This would be a lot better, but no matter. Os synchronize code areas. Ensure that the iCache, dcache are consistent after code modification. That's what it actually does. Low equals low address. High equals high address. Use 0 for memory. And we return none. Actually, we should return a pointer to an error, just to be consistent. Kernel os error synchronize code areas. Uint 32t low, uint 32t high. If low equals 0 and high equals 0, make the definition the same. Synchronize everything. Otherwise, not range from 0 to 2, low, high. Sometimes I get surprised because I remember many of these interfaces, but then a lot of them are really obvious interfaces. Or maybe they're just really obvious to me because I've spent a lot of time working with them. I don't know. Isn't 32 correct choice? It may not be. Dave said, isn't 32 correct for choice for addresses? However, because of the implementation of RISC-OS 64 that I've chosen to do, and the implementation of SWIX, int 32 is all that will be passed through. So if I try and pass it through a 64-bit value, it wouldn't work anyway. So that's why I've chosen that. Probably we should actually have a this is an argument between for how we should handle the transition between 32-bit and 64-bit, and because I've chosen to do this halfway house to make it easier and to make the interface not change between the two parts of the system, it makes it simpler. So one of the reasons that this makes it simpler is if I'd chosen that all values into SWIs are 64-bit, then if you were to pass in a 32-bit value, the varargs implementation changes. It ends up passing in things of different lengths on the stack, which becomes confusing. And it also means that if you were to have a return value that was results here, and it was returning a 64-bit value, but you defined it as uint32t result here, and it was still returning it as a 64-bit value, you've now corrupted your stack. So really, you need to know which interface you're using. It's entirely possible there will need to be a SWI 64 that actually handles this, or that needs to be thought of differently. And this is something that I've encountered a lot of the time along the way, that there are, because of making the decision this is going to be a halfway house, it's simplified some of this code and meant that the code that's already implemented, because a lot of places will already be using SWIs and be expecting a 32-bit value to come back. If it was to change to be a 64-bit value, it would break. It would need code changes. Whereas not needing code changes by using a 32-bit value coming back should work. Of course, if on the other hand they've used ints here, then it's going to break, because if int was to be 64-bit. So there's a number of different things here. So the question is entirely valid, but in my instance of how I've chosen to do this, it's continuing to work. Basically, I'm choosing to do things as close to no changes between 32 and 64, and this is one of the effects that you gain out of it. That's, yeah. If we wanted to go full 64-bit at the same time, a whole lot of other code would need to be updated, and it would become a lot more involved. And maybe that's what should be done. Maybe it should be that for its initial implementation, we do a 32-bit address space implementation, and that never gets distributed. It's just like, this is to try and get things working, and then we make a big step to make that wider and fix up everything else. But we know that it does work when it's in 32-bit address space. You can start making smaller steps to make this work. I do want to move to 64-bit for everything, but I feel I could do that. I feel I could make that happen, and it was one of my original goals, was to go, yeah, I'll do that. But then as I started looking at it, it was like, well, all of these things are going to change. All of these interfaces are going to be different. All of the existing interfaces that pass in structure blocks are going to be different. And people are going to start getting confused between which system they're on and things like that. And basically, nobody's going to adopt the new 64-bit world, because everything's different. And everybody's so close to using these type of interfaces. So realistically, I shouldn't be using this. I should be using oslib, which handles it. So yeah, Dave says you'll ultimately need both forms of interface as well. Yeah, almost certainly. And yes, that makes things more complicated. I am trying to battle a number of constraints. So the constraints are, this has got to work. It's got to start happening and people have got to start seeing something coming out of it. I've got to actually be able to, it's got to be able to be written in a sensible way and not have if-defs all over the place. If you look at the various Linux kernels or FreeBSD and the like, they don't have, or didn't have, different implementations for 32 and 64-bit. They just switched the structure sizes and things worked. That is not the case, because we do have these nasty uses here. And because of that, you've got a community that is very reticent to even start looking at 64-bit. You get people that are saying, when are we going to start doing 64-bit? When we've already started. There is work going on for this, and they're just refusing to accept it. That's fine. But if they're not going to start adopting this stuff, then you've got to make it as easy as possible for them to do so. I'm tempted to argue for a type, ADRA-T, instead of uint32T, and I think that's probably a good... Sorry, that was what Dave said, not me. I think that's pretty sensible. So there's also uint putter. Is it in, or is it int putter? I think uint putter and uint putter exist as well, which is also a thing. I think you're probably right that we want to do that. As for whether they should be here, strictly, you see, you could also argue that this is a void star low, void star high, because it's an address of arbitrary size. I don't know. I think you're probably right that an ADRA-T, but I'd want to make it consistent, and because it would be a non-standard thing, it would probably have to be underscore ADRA-T if we were to actually define it across the whole system. So we'd end up with that ADRA-T there, and that would be defined to be uint32 and uint64 when the address space became bigger. Yeah, I think that would work. Yeah, I think that would probably work. I'm going to leave it for now, but I'm going to start thinking on that because I want to start putting that into all of the headers. I mean, this almost certainly needs a wider discussion. There was some discussion about address space, but I don't feel that there's a lot of discussion on the Viscos open forums about this sort of thing that is being done usefully. A lot of people, when they, I'm kind of complaining now. A lot of people, when they talk about it in terms of high-level interfaces rather than how you actually would implement it here. Like, oh yes, I want tasks to be able to work and stuff like that. Like, yeah, that's way high on the stack. And they don't. There's not a lot of discussion about the low-level stuff. Dave says there's nothing of use on the rule forums at all. That's fair. I've been trying to encourage people on the 64-bit to try and discuss things and to do things. I mean, Simon Wilcox's discussion, I think it was, about trying to change things in big way has been interesting, but not technically giving a lot of value, I don't think. A lot of his discussion is basically, I want Plan 9, which is not a bad idea, but it's not Viscos. So, firstly, it's not Viscos in the sense of it's not like the system we are used to, and maybe that's fine because Viscos was not really like BBC MOS. But also, it's not heavy on the detail on how you actually make that happen and how you transition from one to the other. And that was my dissent on that discussion was you're only thinking about certain parts of the system. You're talking about tasks. What about modules that call modules and the like? I mean, if you don't know that discussion, that's fine. There's a lot of things that are done in Viscos that are necessary, and if you don't really want to keep the current way of working, people are not going to transition to it. So they're not going to move to it. And if you're not going to move to it, then your code base, your user base is going to contract. You're going to find that there's fewer and fewer people even bothering. And I'm not saying I'm right either. This is all based off the whole ADRA discussion and address space size. I do think you're right. And I think Dave brought the ADRA-T type up when we were doing the disassembly code in debugger. And I think it was probably right. Yeah, I think I'm going to start doing a definition of that, because there's going to be a case where there's going to be RISC-OS 64 that is RISC-OS running on 64-bit, and then there's RISC-OS 64 wide, which is going to be the full address space version or something. I'm talking names here that are just off the top of my head, because they will have a lot of different interfaces by necessity. And this is also why, again, little bit of my hobby horse, these changes should have happened many, many years ago. If it had started happening back in, I don't know, 2012 or something, and people had started considering the needs of other systems, this would have been much more advanced and we could have done things. So Dave said, I would assume that it went through a lot of pain too with 16 to 32 to 64. Yeah, I believe so. And I think the same is true of macOS as well. So macOS did the whole keeping some of the interfaces, although macOS is just dropping interfaces. Most of the time, I believe you can still call the Win16 interfaces on modern systems. And if they're not dealing with pointers, they'll probably still work, which is weird. Very weird. Maybe it wouldn't. Maybe that's only when they're in different compatibility versions. I'm not quite sure. Because Windows also has this idea of what type of application you're running. You can run it for Windows of earlier versions. So yeah, I imagine it did. I do remember there's is it W versions on the end of different calls that for the wide versions. I know that the character interfaces all have that for the for UCS2, UTF-16, whatever, whichever one is the correct term. Because I think UCS2 is dead now, and it's UTF-16 for everything. But whatever it was, they had a different interface for that as well. And I'm done with my digression. Yes, I will think on that, but I'm not going to do it now. Why am I not going to do it now? Why am I not going to do it now? What's a good point? Yeah, I could actually do it now, couldn't I? Do I want to do that? It would make this interface easier, wouldn't it? Because I'd just define it as this. It doesn't make any difference to things. Although I did suggest using it as underscore ADRA, didn't I? So I could actually like have it as a, or should it be underscore kernel ADRA? Like that. Like kernel SWI or kernel error. Or just underscore ADRA. There are two things that are really hard in computing: naming things and off by one errors. Also time, but it's 32T, isn't it? So having it as an ADRA T isn't a bad idea. Underscore ADRA T. I'm going to call it underscore ADRA T. Does that make sense, Dave? I'm calling on you as you suggested about. Should I call it an ADRA T? Because then I can migrate it into possibly either SWIs or kernel without changing anything, or should I just call it ADRA T? See, if I call it ADRA T, I believe that's going to clash with things in applications. Whereas if I call it underscore ADRA T, underscores are reserved for the runtime system, and double underscores are reserved for the compiler. Is that right? Oh, I used to know this stuff. So Dave says in his own code, I use whatever t all over the show and technically I'm using the reserved identifiers. I'm going to call it underscore addrety, and if we find that that's wrong, and somebody who knows the C standard and definitions can probably check it, I will go and try looking it up. Dave also suggests anything starting struct clashes with reserved identifiers. Yeah, it's really frustrating that struct anything is reserved. So you can't have a function called strip. You can't have a variable called strip. You can't have a variable called stroll. I'm trying to think of any other word that begins with stra. Strength. Strength is a reserved reserved identifier. Anyway, that in mind, I've now changed that so that except of course it should actually go in the header file, shouldn't it? Because it needs to be available elsewhere. There we are. And then we can put this definition, synchronize code areas. Yeah, there we go. Synchronize code areas. Having the underscores in there just looks ugly. I understand why, but I still think it's ugly. Yeah. We won't worry for now. We've now all of that apart. We're now trying to update this in the variables code. So we need to issue a synchronized code area. So we do OS synchronize code areas from new data to new data plus data length. That is something we can actually. That's uint 8, good. Which of course means that I've got to cast it to an addrety. Because it was a pointer up there. Right, so that will issue that. And so when we read it or we write to it, it will now, we will want to call that code. Okay, so where's the read? Here's the read code. Read the variable. Now. Oh, hang on, what's this do? Read actually retrieves the variable. It doesn't actually retrieve the value. Okay. So retrieving the code variable would need to be done in the OS module call here. Dump, dump, dump. Hang on. That's update. That's because that's set. I want read, don't I? So I want read var val, which is this one up here. So I can check down here. So I don't know if you can see it, but just here, this is where it says SWI read var val, and it says which function I'm currently in. I wonder if I can make that status bar bigger. Settings, default preferences. Status. Doesn't look like I can increase the size of the status bar. I thought there might be a font setting for that, but it doesn't look like it. Next, increase size of status bar text. No, I don't want to increase the font size. Enlarge status bar. Taller or bigger font. font size SM value. It's in the UI theme. UI scale. Oh, UI scale. Do we have that? UI scale, is that a later version? I haven't got it. Huh. One is normal scale, auto detect based on. Okay. I would need to restart it, so I'm not going to do that because it will take a while. Okay. Well, we will not worry about that one just yet. I'm sorry. I'm still trying to find things that work better for doing presentations. So yeah, this is going to be fun. Right. So here we want to do code var read. Where's the variable? Var data var len. Var data is the code, and then we want to put it in a place where we put the data. We're trying. Hang on. Oh, we do the copy, so we just actually need to return the var data and var equals if right. So now we've isolated all of the code variable handling into a different function, which we'll just put up here for now. I may create a new file for it. Should I create a new file for it now? Let's create a new file for it now. New file, code var. New file, code vars. Increment the read the access to code variables. Date. It's the 19th of October 2025. Right, here's what we're going to be doing. Include, well, include ourselves, our own header. Right, so code var read the value of a code variable and its length. Code var points to the code variable to run, and var data points to where to store the variable data, and var data len equals the equals where to store variable data length. And then this is a pointer to an error or null if okay. Kernel os error. Code var read var data and no, I'm just reproducing what it says there. That's dumb, isn't it? I'm going to call this a void start, and I'm going to give this a int 8 t star star, and this is a uint 32 t star. Don't need to put the var on there, do I? I can actually leave the var off because it's obvious it's a var. We're in the variable handling. Okay. Use names. There we go. Right. So what I'll do first is I'll make this a dummy function, and then we'll see that we actually get something that kind of works, and then we'll try and be a bit more clever. All right. So first thing to do is to ignore the var data and just go star data equals hello, and star data len equals 5. Return no error. Okay. We're also going to need kernel.h, and I think we're going to need other things as well, but let's just start with that and create a header file for this. CodeVars. If nedef CodeVars h and CodeVars h. That uses that, doesn't need that. Oh, we also need studint, don't we? Oh, I forgot that. I need to make it build that as well, don't I? So I need to add in CodeVars here. CodeVars. There we go. And then we can build it. Or not. There we are. Ah, yes, we didn't include the header, did we? So let's include the header. Include CodeVars.h. Build. Oh, error isn't defined. Oh, okay, let's just define that. Same here. Kernel error. It's all making me think I should actually be using underscore kernel address for the address thing, as I see this. I mean, I'm not completely convinced, but right. Inventing synchronous code areas. Oh, that's because we don't include any OS interfaces in this. It's possible we shouldn't be doing that because we can rework the code locations later. Node code variables. Well, there will be code variables. Does it have to point as an equal? All right, so it's a uint. Uint 8. There we go. And I said I needed to include studint, but I also needed to include studlib to pull in. Actually, is studlib the place where null is defined, or is it studdef? Where is null defined? I always include studlib, and I have a feeling it should be in studdef. What headers define it? In C++, that's no use. I want C. Old compilers and null. Should be defined in a header. Which header? Oh, it requires it to be provided in all of those. So I'm not going to worry then. CPP reference, that's usually a good bet, isn't it? Ah, but that's for C++, of course, isn't it? Well, fine. I'm not going to worry. It's in studlib and it says that's okay. So we'll do that. Build. I'll build it here then. Okay, it's built. So pyro So we loaded the system variables module. Oh, no we haven't, because it's not, it's moved, it's now in tests. If I do star show sys$date, it says unknown variable type 50. Oh, because we didn't change the variable type either. Variable type is now string, definitely. Go back to here. If it's expanded or the variable type is a code variable, because we've got to that one there. You always do an expansion if it's a code variable. Yeah, then we want to change var type needs to become whatever the one for string is. Interesting. And it becomes a string at the bottom there, and that's okay. Yeah, so all good. Build it first, sorry. Oh, I a while back I started using code spell to try and check things, because I've got lots of mistakes in things where I can't spell words. And one of them that I spotted was I can't spell existence. Existence it should be, not existence. But then non-existent I also get wrong. And equivalent, I think these are things I've actually typoed in the CMunge. Dave says I think it's both. I think it is probably both, but I should try and keep them to consistent ones, because consistent is another word that I can't spell. So I've been trying to use this library called tool called Code Spell, which can go and check things. And one of the things, if I go and where did I use it? Did I do it on ResourceFS? I think I did. Let's go and have a look in ResourceFS. So I look in file sys ResourceFS .code spell. Oh no, maybe not. Yeah, I'd not heard of this either. Dave said he hadn't heard of it. Not in there. Maybe it's in. I've definitely used it in some of these. So SystemVars, OS commands maybe. Commands to code spell RC. There we go. So I copy that to here. Though it obsoletes me. Obsoletes you. .code spell RC. I've also added some magic here, so neither of those words are particularly important, but they do appear in one of the environments. So if I do a code spell now, better. But we've got this successfully, and I'll fix those in a little bit. But right now, yeah, that's another thing that is quite fun. Anyway, because with that in mind, I can then go into here and do. Oh, I thought I had a bill. Maybe I can't. I don't know how it works. I'll have to look into this. It's been a while. Anyway, Pyro. We're trying to test that this works. If I now go and do show sys$date, I get hello. I haven't called it, but I've got the hello out of it. So with this in mind, what I'm going to do now is I'm going to go, let's add CodeVars here. Create a new branch, implement CodeVars. Tentative implementation of the code variables. code variables now return the string hello every time. A little bit of the plumbing is present, but we will need to add the actual calls to read and write. Okay, so that's now going to get pushed and will probably fail and stuff in the tests. So what I'm going to do now is I'm going to go and take a short break, so probably 10 minutes. Might be back at 5 to, it might be a little bit longer, it depends on how I'm feeling, because I need to get myself a drink and maybe something to eat quickly, and then the toilet and things, and then we'll be back. So yeah, 5 to 10, maybe 15-minute break. Back at 3 o'clock, I think will be 2:55 to 3 o'clock. I can type. There we go, and I will see you in a moment. Well, a few moments, I guess. Hello, peoplings. Oh, I think I have to close the blind. It's the window rather. It's getting cold in here. Ooh, it's a bit dark, but yeah, we'll just have to cope. Right, okay. So we're in the process of implementing code variables, which are callback routines that we use inside RISC-OS to read variable values or strings. They're pretty simple. So if we have a look in here, this is where things are implemented. At the moment, we just have a very simple implementation. No, they're not implementing here, they're implementing here. That returns hello. And actually we need to call this variable here. So let us try to do that. Yeah, it's very cold in here. I've got my shirt. Where my shirt is. I might go, I'm okay. Yeah, we're done with summer now. Summer has gone and we are just having to put up with what we've got left. Right, so code variables. Type def struct code vars code variable. So a code variable, if we have a look at this, has this structure here. Entry point for write, entry point for read, and then some arbitrary data. So let us create an entry point for write, which will be an addressee. Var write. Oops, no. And another one, an addressee var read. Actually, no, it's not. It's not an. Oh no, this is an instruction. This is actually code. Yeah, so this is actually code. And I'm going to just type that definite here. So we need to give that an actual type definition, code var t. I've got myself pineapple juice. I can't see that as pineapple juice there, but it is pineapple juice. And I've just been looking at Talia has been doing the pictures for our wedding booklet. She's been sorting those out, so she's made a really gorgeous booklet so far. We've got lots of pictures, so it's quite big. I don't want to cut anything out because they're all wonderful. I always thought it was a bit weird having a picture of your wedding day. It's like, well, surely you remember it, and so no, I now understand it because I do change my mind sometimes. Equals. Oh, I called it code var up there. I'm actually going to call it var data as I declared it there. Code var is a code var t var data. Now this will have different code implementations for 32-bit and 64-bit, but that's okay. Right, and if we have a look at the implementation here, the read entry has you pass it no values and you get back the length of the value and the pointer to a value. So I'll just comment it out, it's not a problem. The way that I have done this is that I got a library called CallX. And CallX is very much like SWIX, SWIX, but it calls a routine rather than calling a SWI. So you do CallX, the code you want to call, and the code here will be codevar ampersand codevar. I can type to var read. The private word will be null, and then the parameters we're going to pass are going to be no entry parameters, but on exit R0 and R2 are important. So out is R0 and out R2, and we return out of there pointer to the value, which is we'll do this as a actually, yeah, we can do it as a into data and data len. We just return it directly into there. And we say error equals, it can also return an error in the same usual way. So start error, and then we return actually equals null. I think that might be all it needs. Probably. Come on, discuss ammo, build it. CallX wouldn't open. CallX/CallX. Oh, shall discuss resources, export lib. Oh, CallX isn't included in there. Oh, bother. Is it in my ASM library? It's in my ASM library, that's why. Okay, that's fine. So in which case it's ASM/CallX. So I know where things live, honest. Riscos shell. I didn't mean Riscos shell, I won't build it. Ammo. Oh, I got those round the wrong way, didn't I? Oops. Yeah, it's all itchy. And now we've got to have CallX included. So if I go down here, O dot. Oh no, it's not in this. It's in my libraries. Libraries is c::asm.o.lib asm. Ta-da! Okay. Come on, where's my run? There's running things. Likelihood of this working? Pretty low, I think. Is that right? Shouldn't it have a year on the end of it? Or don't you put the year on the end of it? I don't know anymore. I actually don't know. dev comment. So sys $. Huh. looks right. So that's what normally it would do. With time. That seems to be working. I've got a system variable, system variable for a code variable which now reads. That's pretty cool. And now we want to be able to write to it. Which should be very similar. So we can take away our magic dummy code here. We don't need that anymore. And we'll have a section of writing code here. Code var write. Read the value of the code variable. No. Write the value to a code variable. Code variable to run. Where store the data we are storing, and this is the data length. Just take a capital T off that. Okay. Right. Thank you, Alan. It is quite cool. I mean, it's genuinely surprising when some of this stuff works, but it is very nice that it does. Right, so for this one, we want to call the write entry point, and we want on entry to the write code. This is the pointer of the value to use, and this is the length, and then everything else is corrupt. So it's R1 and R2. R1. In fact, we'll just do it in 1 to 2. That's it. That's all it needs. But now we need to implement that in the setting code. Header here. Now, this is a bit weird because I'm actually doing the read for the code here, and the write is going to end up being implemented in the other bit of code because you can't do set var val. Oh, maybe I can. This is transforming it on entry. This is set or update. No, it has to happen inside SystemVars or update or create. It's a bit weird that I've got it in two different places. Maybe that's just the design, and maybe it could be tweaked so that it worked a bit better. But right now, I think this is okay. Okay, where are we going? It's create or update, isn't it? Create or update. Here we go. Here's the update code. Context has been set to variable name. This is the bit that does the code setting. So this is different. So if sysvar to type is sv code, that's right, yeah. Otherwise, non-code variable. So we want to do equals code val. Oh, we don't have a way of returning the error here, do we? That's annoying. Actually, this is quite frustrating that I've got it this way because it's Oh dear, those are not the right letters. To value data. And the value we are setting is just data and data then, isn't it? But then I don't have a way of returning the error. SystemVars error. I'm going to cast it. Yeah, that's ugly, but it'll do. Where's my error codes? Here's my error codes. Let's define is OS error. SVE is OS error. SVE. That's all. I'm not sure this is probably all that good, but is it okay to put a pointer inside an enum or cast it to an enum? Not sure that it is. Really not sure that it is. No. Dave says no, and I trust Dave. Enums might be bytes. Yeah, that's what I thought. Bother. Okay, well, we'll just make this into a, for now, a uint 32t. It should actually be a uint pointer, but I don't have uint pointer defined at the moment. This one, isn't it? Yep, there we go. And then control, is it? Yeah, that one there. I was to turn this nice enum that I've carefully defined into, oops, into a ugly definition like this. it'll be okay. What's the worst that can happen? I think this is better anyway. Now I'm going to get a whole load of errors in my code because these things are not defined as they were, but that's okay. Although I do also want to go and change anything else that referred to SVEs in here. Nope, nothing else in there. So in variables, we want to look for SVEs, SVE bad type, SVE, this one's better. This is SVE 2 from OS error. That. And that should be the case. Is there SVE there? Any more? Yes, it's fine, 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 not fine. Another one there. And we're done. Okay. So almost certainly there'll be some in module here. Here we go. Here's some. And this one as well. If SVE is OS error, return SVE from to OS error. Yeah, there we go. Any more SVEs? Here we go. Oh, was that the only ones? Huh. Oh, that's cool. I suspect it'll still be broken. We'll have to see what happens, I suppose. No side effect in void context. I thought I defined it to be a uint. I thought maybe I didn't. Maybe I just. Oh, T. Build again. Yeah, okay, that's fine. Yeah, I haven't included CodeVars in. So this is wrong because this particular library shouldn't have any RISC specific things in it. That's what I've tried to make it do, and I've broken that rule. So yeah, I could have a rethink about how it works, I suppose. 349. Okay, let's have a look at that. Implicit cast of pointer to int. From OS error. Did I get my cast around the wrong way? I did. This is a sys error. Okay. Okay. This will probably crash. We'll probably end up doing something badly here. Right. Show sys_time. Still working. Set sys$time to be 55,55,55. Bad system variable type. Interesting. Right. If the variable type is not the type that was expected, for everything else we do that. If it's a code variable, right, if type is SVT code, they want to set a code variable. And a non-code variable exists. Delete the variable. And then create the code variable. So delete it is where's the code for delete? I'm sure there's some code here for delete, isn't there? Delete, there we go. SystemVars delete just gives it, yeah, that's all we do. So we do SystemVars delete of CS. If failed to delete it, I don't know why we'd fail to delete it, but in fact, if it fails to delete, I think we'll return bad type. So if we do, we just report bad type. Okay, and then we create the code variable, which means we go right back to this bit and we do this section here. Create the code variable is that, and that will create as a code variable in place of the non-code variable. So here, if the type, that one is code, only strings are supported, aren't they? If type which are the ones that are strings? So these ones here, isn't it? It's string and literal. We pass those through in a standard form, don't we? SVT string, it always comes through as SVT string. So if it's not SVT string, we can't do it. There we go. And then everything else just passes through. Okay. Build that. And run it. Cannot set time. I haven't implemented time setting yet, so you can't do it. init resolver. Ooh, system variable not found. Interesting. I think it tried to deregister one of its variables and then found it didn't exist anymore, and so it got upset. Maybe it shouldn't do that. And if we do show inet star now, there we go. I think inet $hostname, it's identified. This, my machine is called Mooncake. It's identified that. So I do set inet $hostname to be foo. I think that went through a code variable. I think it did. But as I don't have any debug in here, I can't tell. It's a bit dumb, isn't it? Let's see if we can turn some debug on, and then we'll have a see. So read, let's actually go and, yeah, there we go, delete. Delete needs to be special cased for wildcards as well, because you can't delete a code variable without using a special code. You've got to use variable number 16 and do it that way, otherwise it doesn't delete it. Do you like Mooncake? I've always wondered. Mooncake is cute. Mooncake, I don't know if Mooncake is really a thing, but Mooncake was the little green blob thing in Final Space, and that's why it's called Mooncake. Mooncake in Final Space. Mooncake! Shoppity! Shoppity pock! I'm a little bit sad. Final Space is fun. But yes, that's Mooncake. I am so sad. Oh, I don't have any other pictures. It's a universe-destroying creature who happens to be the friend of Gary, who's the quite bizarre anti-hero, I suppose. Gary Goodspeed. Anyway, close that. Back to where I was trying to do code. That's where Mooncake comes from. So I've got Mooncake here. This laptop's called Mooncake. The really old laptop is called Laputa because it was a flying city, and I can't remember what the other one's called. Yeah, sorry, it's named after a cartoon character, I'm afraid. I can't remember what that laptop's called. Nah, not a clue. Oh well, I'm sure it'll come to me. Right, so I was trying to add in some debug to say what we're trying to do here. So actually, wouldn't it be better if I put it into here with some debug in the code vars, because I'm going to actually see it in the code vars. Back to the top, please. Spin to the top. Grab the debug code here. Sorry, just smiling at my wife. Sorry, I'll stop grinning and just. that's what I'm doing. I'm putting them to debug, aren't I? So it's, yeah. Reading code variable. Data. Oh, start data. Start data. There we go. That'll print out what we read. And this one we can do writing code variable. Oh, actually that's wrong, isn't it? If that doesn't look the same indentation. Well, it usually does two then, so stupid. Let's start with data and sorry, data len and data, and then again we use the same code here pretty much to say that we were successful. Right, let's try that again. I'll build it first. Build. I didn't mean that. It's already built. Run. Whoa. Lots of debug. Maybe I shouldn't have put the debug on variables. Maybe that was excessive. We'll let it finish. Right. Okay. This is where you can see that not caching anything and not having any fast lookups is actually a problem because it's doing a lot of work there. If we have a look at these, we can see this. Ooh. Reading code variable. Reading code variable. Reading code variable. So if we do set now, set hostname to foo, writing code variable foo. So yes, we have code variables working. This is nice. So that's turned off. Let's turn off the debug on this because we know this is working. And then build it again. Oop, code vars. Just need to include studio in there. Right. Okay. Lots and lots of differences here. Implementation of code variables now works in ARC32. It does not work in 64-bit yet though. The implementation of the 32-bit code variables working. And it can't work because we don't have a 64-bit underscore callx. However, that is easy to implement. I'm saying it's easy to implement and just going, well, of course it's going to be easy to implement, because why wouldn't it be? It's going to be difficult. So what I'm going to do is I'm going to implement it here, and then I'm going to lift the code and move it into the C library, because it sort of it should be in there, I think. It makes the most sense to be in there. It can go in as underscore callx, exactly as we've got here. And then it will be nice and easy to use. So first thing to do is to find the code. So let's see if we can find it. I'll open a new window. We'll just quickly make this work. Well, try and get something to work. If I have a look in // build headers, not clibs, asm. Yeah. Check out master, please. Catch up. And let's have a look at it. So, it's all in assembler. It's all in assembler. I am not going to re-implement this in assembler. Yeah, this is just ugly. What I am going to do is ditch that, and instead we will go and use the projects row. What's it called? C library. But the C library isn't called it's still called simple binaries in my code here. It used to be called 64 clib blob or something. Or was it test blob? I can't remember. It's gone through a number of different names. And in clib, so have a look in here. I'll pull up the source code. So in here we have, is it in kernel? Yeah, SWI is here. So this is the implementation of SWI. And as you can see, it's literally just check variables are set. If they are, do it and then call kernel SWI and then copy the error. That's all we're doing. It's not particularly difficult, isn't SWI? And then kernel SWI actually does the call with these registers. I have chosen in this instance to not implement a lot of this in assembler, because I don't like working in assembler. I don't see any point in writing complicated things. Actually, for SWI, it would make a lot more sense to be in assembler, but I don't really fancy it. It's an optimization that I'm not needing. So what we're going to do is we're going to implement it in here. So here we go, new file, callx64, and then new one here called callx64 as well. And what we'll do is we'll just pinch the entire implementation of SWI and put it there. Don't think copy error is actually exported. I'll see what it is. We'll have a see. Yeah, we'll see if it's implemented. And we'll do kernel call instead of. Ooh, maybe that's a bad name. Yeah, call's fine. It'll do. And we're not using a SWI number. We are instead using a void star, which is the func, and a void star, which is the a func, and then a func pw, private word. Void star func, void star func pw, and then the flags and so on. Callx, call, Oops, no, not a function. So this is called callx 64 simple implementation of underscore flags. 19th of October. And we need to know, we need to include kernel.h, and we need studint, and we need studarg as well. And we're not using flags, it's fine, I'm not going to worry about those. I'll just quickly prototype what this function is going to be. Actually, it will be very similar to this one, to be honest. So a prototype for this is, you missed that, press the wrong buttons. Kernel call. And this is exactly the same, well, pretty much the same as SWI underscore regs, I think it is. Are in pointer, sorry. Are out. There we go. Yep, looks good. And then we can create a S directory. For the implementation of this, implement kernel call. So if I have a look in here, we should find there's some assembler code. Where is the assembler code? It's actually down here. It's not meant to be. That's the SWIs. Is kernel SWI in here? No, it's not. This one. There's kernel SWI. Kernel SWI implemented in gas, which I don't like. So let's not implement it in gas. We're going to do it in Objasm, because why not? Call 64. Yeah, this is going to have to be in Objasm, isn't it? Because that's what S file directories use. Yeah, fine. Area. I'm going to call it c.rcode, so it links into the C code area. It's going to be a code area and it's read only. Export underscore kernel call. Func pw. Okay. So kernel call. I'm going to want a signature there, but I'm just going to leave it for now. Right, so stack the registers. That's manipulating the SWI number. Don't care about that. Oh, except I do want to move the SWI number out the way, don't I? So when I come down to here, where is it? Get that out of the way. This is where we call the SWI. So we actually want to do the stuff there. So mov are what is it? 0 and 1. I'll just put it in like R14 or something. That's like X14 of X15. X14 function X15.2 equals private word. I could even put that into R12 now, because R12 is going to be safe. There we go, 12. In fact, if it's going to be 12, let's make this one 13 and make it nice and tidy. Or even make it on 11. 11 and 12. 11 and 12, there's a nice pair, isn't it? And then all of this goes away because we don't care. Oh, except no. Our 11 was getting set to the output registers are 10. So X10, R10. Okay. This should be 2, and that should have been 3. Input registers going to R12. Oh, can't use R12 there. I'll just use R14 because that's safe. Actually, 13 is safe as well, isn't it? And this comes from 2. Load the registers. So this we was talking about earlier about the SWI implementation using 32-bit. This is what makes sure it uses 32-bit. We're only using load into W registers rather than X registers, which are 32-bit wide. All of this needs to change to 13. That's not confusing at all because it's a stack pointer. Branch to register are in X11 and do addr. Actually, you can actually do this BLR, can't you? I forgot about that. Yes, and then we don't even have to set up R30 ourselves automatically at all. R10 contains the SWI number. Ooh, that's interesting. These are corruptible. I'll rewrite this routine offline when I move it to the C library because at the moment you can't use a bare C routine because of the fact we're relying on those registers being preserved. It'll be okay when we're using it through the CMHG veneer, but it won't work otherwise. There we go. Move our 12. Oh, that's the R10. Hang on, I'm getting confused now. Output registers are in R10. Yeah, we can move this into R12 here. And then R12 into R0, and then restore, and that'll give us our error return. And then we do end at the end here. And in Objasm, you don't have colons on the end of labels. I think that should be valid code. Probably, maybe, possibly, don't know. Have to find out. Wave hands, hope. Oh, I'm in complete darkness here. It's just got dark. Oh, I need to sort out my lighting in here, don't I? Right, let's give this a whirl. Likelihood of it working is pretty low as I've just hacked this together, but we can give it a whirl nonetheless. So what we do is ifec build 64 1. If we are building 64, obj plus equals o.callx and callx 64 and that else, and that's where we can do libs. We can do this bit here so that the 32-bit version uses asmlib, or libasm rather, whatever it's called. And and that can be made just empty. And then if I go back to SystemVars here, ammo, let's see if we can build any of this. This is 32-bit build. Right, Viscous ammo, clean it all up and build it again. Just make sure it's nice and working. Okay, that's good. Now we'll do the same clean for build 64. And we'll then build that. This is where we'll probably fall apart. Unrecognized parameter, call x, call 64 to s. Oh, that's a pity. I thought I'd made that stuff work. I just build it with s dot call 64. Does that work? No, it transforms it still. Oh, I thought I got my Objasm working. Right, I can't remember how this works. Viscous shell. Put it into a shell. Run that. Okay. RO build RO64 underscore CLI transform underscore debug equals 1. No, that's not the command to use then. Is it row build CLI transform? Ah, there we go. So we ran this command here. And it said it didn't understand it. I think the CLI transform is not meant to be doing that, or Objasm is failing to spot the fact that it's so it has converted it to a CLI call 64.s there, but I think Objasm is getting confused. Unrecognized parameter. I think it thinks it's already got an input and an output. What was it trying to run? I wonder if these predefines are causing it to get confused, because it doesn't look like they're quoted there. Is that what's going on? That would be really dumb. Let me just do it manually with those. Minus I empty. Minus I empty isn't a good idea. Oh, minus I at. It's got minus I at there, and then it's turned it into an empty string when it's converted it here. I think that's what it's actually confused by. Yeah, there we go. I've now got to call it Z64 in there. Okay, so something about the include of at has caused it to get confused, and I think that's purely happening in the callx code, because I passed it in. It was in the input parameters, it's there, but by the time it gets the output parameters, it's lost the anything in there. So it's doing -i predefine, and this has ended up being some other part of the parameters, so it's got confused. Okay, I can fix that. This is the other reason why we try and test these things. Yeah, I don't think kernel copy error exists. It doesn't like that expansion, cast from pointer of int to a different size. Did I actually implement any of this for the 64-bit? I didn't, did I? I've just got the right code, yeah. So the implementation for 64-bit code variables is different. Yeah, copy var error shouldn't be there. Let's just get rid of that. I might add that back in later, but for now it can go. Right, if def riscos 64, so for the 32-bit side, we have this form, and for the 64-bit side, we have a slightly different format. So if we have a look in, what's it called? Riscos.pyro. No, it's Pyromaniac. Oh, I don't know my own blooming website anymore, do I? SWIs, PRMs, 64-bit interfaces, and we look in setvar val, or is it under, yeah, code variables. Here we go. So the new definition of this is a 16-byte block that contains 8 bytes of the address of the write entry, and 8 bytes is the address of the read entry. There's no code involved in the code variable. All the code is just referenced. And this means we're not copying code around, so we don't have to do synchronized code variables, and we haven't got an arbitrary section of code that's actually being executed. We've just got point references to code, which makes it a much more nice interface. And again, same things here as these. The slight difference is that R2 contains the workspace pointer. Interesting, because that's necessary, isn't it? Yeah. But I'm not implemented workspace pointers yet, but we will get to that. So this isn't an instra, it's actually an addra. Oops, instra addra. So when we're reading, this is going to be slightly different. If def riscos 64, otherwise this. We do a very similar set of code. So for read, R0 contains 0. Read entry point, R0 contains 0. R1 contains 0. R2 contains the private word pointer. Oh, hang on, that's so in 2. So 0, 0, private word. And we're going to set the private word to be 0. So 0, 1, 2, and then out 0 and out 1. On read, x1 will contain the pointer to the read data, x2 will contain the size. That's interesting. I've moved it. Why have I moved it? Did I mean to move it? Oh, because R0 contains the error pointer. That's right, it doesn't need to set the V flag. Interesting. So R0 all the way to R2. Yes, that's because I was trying to avoid using the V flag. So if or if not and R0 yeah, it's going to be a little bit weird, this one, but okay. So that's the code for reading. And the code for writing should be very similar. The reason that these magic values in these two registers are there is R0 means that it can pass through quite happily if it wasn't doing anything, and X1 can contain 0 to indicate that there's a value set. And on the writing entry point, you've got value to write and the length, so both R0 and R1 will be set to valid values, and R2 continues to contain the workspace pointer. All of which makes it quite easy to understand. And then on return, you've got the X0 again being the error pointer and nothing else. I think it makes sense anyway. So this one is data and data row. And there we go. I think that's the implementation of 64-bit code variables. If it is, it'll be quite impressive. I know I've run over a little bit, but I don't think this is too bad. Oh dear. I didn't declare it in this function, so star pw and void star r0 equals naught, null, equals null. Both of those should be assigned to null. Yeah, that should be null. We build that with the internal build, it'll be easier to trace. Declare but not used, that's fine. Yeah, okay. Build 64.6 built. Unknown type. Where did I define that? Was it in OS? It was in os.h, wasn't it? So I can put that in here. Okay, PyroDev. 64-bit. 64-bit version of the module, 64-bit version of the defaults module. That didn't work so well, did it? That did not work well. Yeah, it looks like I screwed up my implementation of kernel SWI. Ooh, that's you calling kernel call. Did I get var called kernel call? How did I what? Did I make a mess of the assembler code? Kernel call. Ooh, that's wrong. This is maybe jumping to the wrong bit of code. underscore kernel SWI replaced with underscore kernel call. I don't think that's wrong, but let's just rebuild that again. I've got to go through my nasty hack again to make that work. There we go, nasty hack. Exit out of that and then build again. No, it's still broken. Still badly broken. Yeah. That's interesting, isn't it? Output registers. This all looks fine to me. Where did we start to go wrong? Actually, let's clear this and start it again, and we'll just have another look at it. Lots of output. Right. SystemVars got initialized, and then we went into the SystemVars defaults, and then we broke. Is that the return from kernel SWI? Got an error pointer that's invalid. Error pointer is not valid memory, so it's returning back with an error pointer that's garbage from kernel SWI. So it called our SWI and got back garbage. It implies that we're returning garbage as an error pointer, which we could be. You know what would help? If I turn the debug on. Oh no, don't do that. Sorry. Stop. Bother. Let's go build it again with the debug on, and then we'll try it from the top. How odd. I've just built the wrong thing. Discuss ammo build 64 equals 1. And try again. Right. SystemVars initialized, again, invalid memory. How odd. I mean, it looks like that's actually the error code and this is the error message. It looks like we've got the actual error pointer has been loaded from, which is odd. But we also didn't print out any messages saying we were reading. Is that broken? So let's get rid of our SystemVars module and just use the SystemVars defaults. Well, that works fine. So it's not that. It's something else. Oh. I mean, it could mean a lot of things are broken, really, but let's put the debug into the main module. Nope, no, not that. Read var val %s. So we'll at least get a call to say what we're trying to do. We're reading value of CS. We'll hope that it's got 0 termination on it. Dprintf, sorry. And we'll report here not found. And buffer overflow, buffer overflow again, and then red value. Okay, and then set var val, we can have some similar messages here. CS. That's the transforms. Turns with error percent p I SWI error. So either it'll be a constant or it'll be an error message, and we can have a look at that. Okay. And this is set OK. All right. Build and run. Oh no, that's not the right one. Sorry, stop. I want the other. That one there. Yes, yes, you built it. Thank you very much. Control C did not terminate the build process. I wonder why. I thought that should have been caught. I thought I'd put something in it. No matter. Right. Read var val systime not found, and then we get back not valid memory. Huh. I think I know what this is. Let's try this. If this works, I'll be very cross. I changed the definition of how things are returned inside CMunge. Oh! And errors are returned in a slightly different way now. No. And that might be the reason. Might not. I thought I'd cleaned everything though. should have worked. I might be looking into this in my not live time. We're really running over. I want to get finished. Come on. Yeah, it's broken. Broken. See, that header is looking wrong. Well, not the return is looking wrong. If we're in 64-bit, it's this way, and that's what I should be seeing. But it's returning, it feels like it's returning the wrong value back. Right, well, anyway, c/callx 64, h/callx 64s. Right, so I've got most of this implemented. In 32-bit. In 32-bit implementation of the code variables works okay and has been running okay for the standard modules. However, the 64-bit implementation is returning strange error blocks which are invalid. These need to be investigated. It might be Siemens breakage. It might be, actually that's all I can think of. Okay. Oops. Right, so code variables pretty much implemented but not quite finished. I'm going to try and finish those offline and have an investigate what's going on, because I do think it's CMunge. And fingers crossed that will then show up what's wrong with it. All of this is basically improving my build environment, so that's good. I've also got to fix the Objasm problem where that include came out rather weirdly. I think I know what I need to do. I just need to do a replacement of at with dot, but I need to see how the CLI transformations work. So I'll have a look at that in a little bit. What did we manage to do today? So today we've managed to get the OS SWI implementation implemented. So we can now claim those OS SWIs and we can turn that on and off. So we can use it as a, not on a RISC-OS Pyromaniac or RISC-OS 4 system. We've made it so that code variables are implemented in 32-bit. The 64-bit is nearly there, but we're getting some weird error returns. I suspect that that's CMunge, and I will look into that offline. Next week, I mean, we're nearly there. I mean, there's a bunch of error conditions. I think deleting code variables is one of them, and a couple of others. What I'm hoping I'll be able to do is to pick up the RISC-OS Pyromaniac system variable tests and drop them in here in the same way as we did with debugger, and we'll be able to see what's going on and get some parts of the code tested in the same way. Well, that will definitely show up some discrepancies in it, and then we might be at a point where we're in a happy place with it. Right, that is the plan anyway. We'll see whether we get there. Good to see everybody, and hopefully we'll have some other interesting things next week. All right, see you all later, and yeah, enjoy. Bye.